Hello, welcome to week 3, video number 2. Today we're going to study a little bit about the enthalpy of solution. We've talked about enthalpy in the past. It's the actual heat energy that exists within something. And so we're going to talk a little bit about that and how solutions in that are affected, and how the enthalpy is affected by the different solutions. This is starting on page 205, where it says enthalpy of solution in the first column. So the solution process is pretty much a 3-part process. When you go back to the very first part of chapter 12, when we were first talking about it, when we were putting sugar in water again, the solute particles, they separate from their crystals as they are mixed in either physically or just naturally doing it over time. And as they separate, the second part is that the solvent itself, molecules, move in and move apart and allow the solute to intermix completely and totally be surrounded by the solvent. And then the third part of it is when they actually interact with each other. So the first is the starting to separate. The next is the solvent moving in and surrounding it and allowing room for them. And then the third part is their interaction. Now, the first 2 steps, the separating and moving in, is usually what is called endothermic, meaning that energy usually is put into it in order to make that work, be it somebody stirring something or whatever. Energy is actually put into the item. And the third one, the intermixing, the third step usually releases energy and is exothermic. And the amount of energy that's involved in each one of these can affect the actual enthalpy. So enthalpy again is the heat of solution. We show it as the delta sign for the change of heat, and then you just put a solution, something like that, the heat of solution. That would be how you would show that you're talking about the enthalpy or the change in its internal energy. So if you're putting energy in, that energy is going into it. This is going to increase. If it's exothermic, it's going to be releasing that energy out of itself to somewhere else, and this will actually go down because it gave it away. Now, many solids have a positive enthalpy, or they're endothermic, meaning that energy had to come into them. They're bringing it in because the energy that's required to separate them isn't that big a deal, and they just absorb it. Now, most gases, though, have a negative enthalpy, and they're exothermic. And sometimes if you dilute a more concentrated solution, it can cause an absorption or a liberation of heat, depending upon what the solution is. And I want you to look on page 205 at table 12.5, the enthalpy of solutions, and it gives you some of the amount of, it says kilojoules per mole of solution in 200 moles of H2O. So if you were to put, for instance, if you look down and you see the KCl, or the potassium chloride, and you put that into the water, it says plus 17.6. It's going to absorb energy in, probably cooling as it absorbs the energy into it. Okay? Let's find one that's a negative one here that's a little bit on the bigger side. So like sodium hydroxide, it's on the second column, most of the way down is the NaOH solid. If you put that into the water, it's got a minus 41 kilojoules of energy. That means it's going to be releasing that amount of energy, so it would get hot. Now, where this is used practical, or a practical use for this is in a lot of medical kits, sports injury medicine, going skiing. There's all kinds of these things where we have some of this kind of stuff going on, where you have these little bags that are in plastic, and there's usually some kind of a hard piece inside that you break and shake up, and you intermix these two pieces together, and some of them will be cold packs and some of them will be hot packs, and you can put it on like sprains, or if you're skiing, some people will stick them in their pockets and they give off a little bit of heat over time. There's a lot of different ways that these kinds of things are used, and they're usually a one-time use for this kind of a thing. But what's happening is you're intermixing, and depending on whether it's endothermic or exothermic, if it's endothermic, it's going to be absorbing heat and it's going to feel cold. And so you'll get that icy cold pack. And on page 206, if you turn over the page at the top, it says instant hot and cold packs. That's what's happening in those. I would recommend that you read through that. It's only a couple of paragraphs, it's pretty short, and it'll help you to gain a little bit more of an understanding of what's going on there. But that's basically what's happening, is that you're mixing those up and they're being used. Now, for the last of today's lesson, I want you to do the 6 questions that are on page 206. It says section review 12.2. There's just 6 questions that kind of go over what we've gone over in the last 2, and that will finish the second video for our 3rd week doing class this way. We'll see you next time. Thanks.